Welcome to part 3 of chapter 6. In this part we will talk about sequencing activities. Sequencing activities for a project involves reviewing individual activities and determining their dependencies first. A dependency or relationship is the sequencing of a project activities or tasks. So what it means if task A somehow depends on task B, on the outcomes of task B, then task B has to be done before task A. So you must determine those dependencies in order to use critical path. You must determine those dependencies in order to imagine or visualize how those tasks will look on a timeline, and also to be able to do critical path analysis later on. Critical path analysis can be viewed as an optimization technique with respect to the time dimension that is frequently used in project management. So we'll talk about critical path analysis a bit later. Activities are often sequenced and visualized using the so-called network diagrams. So this is a preferred technique for showing activity sequencing. A network diagram is a schematic display of the logical relationships among activities, or the sequence of those activities, or both, right? Both the logical relationships between different tasks and activities, and the sequence of those activities. There are two main formats for creating network diagrams, two popular formats. One is the so-called arrow method, and the second one is precedence diagramming method, and we'll look briefly at both. The first method we'll look at is the so-called arrow diagramming method, or ADM. It is also called sometimes as activity on arrow network diagram. The reason it's called activity on arrow is that activities on a diagram under this approach are visualized as arrows. So activities are represented as arrows. Nodes or circles are the starting and ending points of activities. Unfortunately, the so-called arrow diagramming method, or ADM, has a limited utility, as that it can only show finish to start dependencies. In other words, the kind of logical dependencies among tasks that can be visualized using this method are quite limited. So finish to start dependencies means that one task has to be finished before the other one starts. So to continue that thought, here this diagram means that task A, represented by arrow, needs to be finished before task D starts. And here you have an example of the so-called activity on arrow diagram for a project. So here arrows represent activities. For example, this arrow represents activity B. There are durations assigned to each of the activities, so the activity B has a duration of 2 days. And then those circles or nodes, they represent starting and ending points of activity. So node 1 represents the starting point for activity A, B, and C. And then node 3 represents the ending point for activity B, right? So activity B needs to end before you start activity E. And in this case, the node with the number 3 represents the starting point for activity E. So that's one method to visualize the entire sequence of activities for a particular project, and it's called activity on arrow, or the so-called arrow diagramming method. Now the second more popular method is the so-called precedence diagramming method, or PDM. Under this method, activities are represented by boxes, and arrows show relationships between those activities. It's more popular than arrow diagramming method and is used by project management software such as Microsoft Project. It's also the reason it's more popular, and the reason it's widely used by different software applications, is that it's much better at showing different types of dependencies, or different logical relationships between activities. So those are the kind of task dependencies you can visualize using the so-called precedence diagramming method. First of all, the most common one, finish to start, or FS. So finish to start means task B cannot start until task A finishes. Or to phrase it differently, task A has to be completed before task B starts. So what would be an example of this kind of dependency? Something along the lines where task A represents finalizing requirements towards an information system, and task B represents software development efforts. So requirements need to be finalized before software development starts. So that's the nature of the relationship that is called finish to start. Then you have start to start. Task B cannot start until task A starts. Okay. To rephrase that, both tasks need to start at the same time. An example of tasks that have this kind of that kind of logical relationship would be, let's say, development and testing, right? So testing, task B cannot start until you start development. Once you start development, you can start testing the individual codes or components of your code, individual modules or components of your code. Finish to finish. Task B cannot finish, right, until task A also finishes. You can pause for a second and think about, and think about an example involving two tasks where one task cannot finish until task B also finishes, right? So pause for a second and think about an example. I mean, one example that I see, maybe it's a bit too high level, but task B can be monitoring and controlling, and task A could be, the entire project, right? So monitoring and controlling task B cannot finish until you finish the project, right? So that's another relationship. Then you have start to finish relationship. Task B cannot finish until task A starts. So it's kind of similar to this, but the logic is a bit different. Task B cannot finish until task A starts, right? So an example of this kind of relationship could be something along the lines where task B is the operation and management of a system using the project management team. And task A is operation or management of the same information system using internal in-house team of the organization. So task B cannot finish. In other words, you as a project team, you cannot stop maintaining the system until the internal organizational team overtakes operational management of the system, right? So basically this point signifies the transfer of ownership or transfer of responsibility for the system from your project team to the organizational IT department, right? So and if the system needs to be up and running 24/7, then you cannot finish task B. You cannot finish as a project team. You cannot finish supporting the system until the other team is ready to maintain it, right? So there should be any gap between B and A. So those are the kind of relationship you can represent or you can visualize with the help of the so-called precedence diagramming method. Now, under precedence diagramming method, the networking diagram, the final product would look something along those lines. So you have activities represented by blocks or rectangles, like you have activity A, B, and D, E, H. Each activity has certain attributes, meaning additional information about the task or activity. For example, start date, finish date, resources required, duration, ID, and then arrows represent dependencies. So here, task D depends on task A, meaning task A needs to be completed before you start task D. And note here you see something called critical path. Critical path means the longest path from the starting point until the completion of a project. So you see there are many paths here. You have this path, you have this path, you have this path, you have this path, but this one seems to be the longest one, and that's something called critical path, meaning the longest path through the network diagram, and this is something we're going to talk about in other parts of chapter 6. So this completes part 3 of chapter 6. Thank you for watching.